Hey there students, it's Miss Adams, and in this video we're going to learn how to solve absolute value equations. Alright, properties of absolute values. If we let a and b be real numbers, then the following properties are true. The absolute value of a has to be greater than or equal to 0. The absolute value of negative a is equal to the absolute value of positive a. The absolute value of a times b is equal to the absolute value of a times the absolute value of b. And the absolute value of a over b is equal to the absolute value of a over the absolute value of b. However, b cannot equal 0. Solving absolute value equations. To solve, the absolute value of ax plus b equals c, where c is greater than or equal to 0. Solve the related linear equation. Ax plus b equals c, or ax plus b equals negative c, where c is less than 0, the absolute value of the equation ax plus b equals c has no solution because the absolute value represents a distance and cannot be negative. All right, solving absolute value equations. The absolute value of x minus 4 equals 6, x minus 4 equals 6, and x minus 4 equals negative 6. I'm going to split them up into two separate equations. And then I'm going to solve each one independently. So I'm going to add 4 to each side. I get x equals 10. And the other one, I'm going to add 4 to each side. Negative 6 plus 4 is negative 2. So the solutions are 10 and negative 2. And then you want to go back and check these. So you plug them in. 10 minus 4 is 6. Absolute value of 6 is 6. Negative 2 minus 4 is negative 6. Absolute value of negative 6 is 6. All right, so you want to get in the habit of checking your work when you're working with absolute values. Make sure they're both working solutions. All right, the absolute value of 3x plus 1 equals negative 5. I'm going to write this as 3x plus 1 equals negative 5, and 3x plus 1 equals positive 5. Move the 1 over. I get 3x equals negative 6. Divide by 3. I get x equals negative 2. If I plug that in, 3 times negative 2 is negative 6. Negative 6 plus 1 is negative 5. The absolute value of negative 5 is 5, so it cannot equal 5. So that is actually an extraneous solution. And then if I do the other one, if I move over the 1, I get 4. Divide by 3, I get 1.33. If I plug that in, 3 times 4/3 is 4, plus 1 is 5. Absolute value of 5 is 5. And not negative 5. So this one actually has no solution. Okay, so again, when it equals a negative, it's going to have no solution. Number 3, the absolute value of 2x plus 7 equals 3. I'm going to set it up as 2x plus 7 equals 3, and 2x plus 7 equals negative 3. I'm going to move the 7's over. 3 minus 7 is negative 4. Divide by 2. I get x equals negative 2. And then I'm going to move the 7 again here. Negative 3 minus 7 is negative 10. Divided by 2 is negative 5. If I check these, 2 times negative 2 is negative 4. Negative 4 plus 7 is 3. Absolute value of 3 is 3. If I plug in negative 5, 2 times negative 5 is negative 10. Negative 10 plus 7 is negative 3. Absolute value of negative 3 is positive 3. So the solutions are negative 2 and negative 5. All right, solving multi-step absolute value equations. First thing I'm going to do is move over the 10. All right, so I get absolute value of 3x plus 9 equals 6. So I have 3x plus 9 equals 6, and 3x plus 9 equals negative 6. I'm going to solve for x by subtracting the 9 on both sides, dividing by 3 on both sides. I get x equals negative 1. And then I'm going to do the same on the other side. I get 3x equals negative 15. Divide by 3, x equals negative 5. And again, we want to check these. And when we check them, they do work. All right. The next one, I have 2 times the absolute value of 4x plus 1 equals 8. I'm going to get rid of the 2 to get the absolute value by itself. The 2 is connected by multiplication, so I'm going to undo it with division. All right, I'm going to get rid of that first before I split them up. So I want to have the absolute value isolated before I split it up into two separate equations. All right, so I have 4x plus 1 equals 8 divided by 2 is 4. Now I have the absolute value isolated, and I'm going to write two separate equations. So 4x plus 1 equals 4, and 4x plus 1 equals negative 4. I'm going to solve for x by moving the 1 over, dividing by 4. I get x equals 3/4. Then the same on the other one. I'm going to move the 1 over, divide by 4. I get x equals negative 5/4. And we want to check those. All right, if I check those, they do work. So my solutions are 3/4 and negative 5/4. All right, number 3, I have negative 4 times the absolute value of 5x minus 2 plus 3 equals negative 9. Again, I want to isolate the absolute value part, so I got to get rid of that 3 and the negative 4 before I can separate into two equations. So I'm going to move the 3 first by subtracting 3 on both sides. That gives me negative 4 times the absolute value of 5x minus 2 equals negative 12. I'm going to get rid of the negative 4. It's connected by multiplication, so I'm going to divide. I get absolute value of 5x minus 2 is equal to positive 3. Now I can write this as two separate equations. 5x minus 2 equals 3, and 5x minus 2 equals negative 3. I'm going to solve for x. Add 2 to both sides, divide by 5. I get x equals 1. And then if I solve the other one, I'm going to add 2 to both sides, divide by 5. I get x equals negative 1/5. And I do want to check these. All right, and checking those does work. So my solutions are 1 and negative 5, or 1 and negative 1/5, excuse me. All right, solving equations with two absolute values. Solving the equation with two absolute values to solve the absolute value of ax plus b equals the absolute value of cx plus d. Solve the related linear equation. Ax plus b equals cx plus d, or ax plus b equals negative cx plus d. And make sure when you're doing the negative, you're doing it to all the pieces in that second absolute value. All right, so absolute value of 3x minus 4 equals the absolute value of x. I would write two separate equations. 3x minus 4 equals x, and 3x minus 4 equals negative x. And then solve. I'm going to move the x's over to get them to one side. I have negative 4 equals negative 2x, divide by negative 2 to get x by itself. I get x equals positive 2. And the other side, I'm going to move the x's to one side, divide by negative 4. I get x equals 1. We could check these, make sure that they work. All right, so the solutions are 1 and 2. The next one, 4x minus 10 equals 2 times 3x plus 1, and 4x minus 10 equals 2 times negative 3x plus 1. Okay, we're going to distribute the 2. I'm going to move the x's to one side. I'm going to get rid of the plain numbers to get the constants on one side. I get negative 12 equals 2x divided by 2. I get x equals negative 6. On the other one, I'm going to first start by distributing the negative, and then I'm going to distribute the 2. I'm going to move the x terms to one side. I'm going to move the constants to one side. I'm going to get x by itself. I get x equals 4/5, and then I'm going to check my solutions. All right, examples 5 and 6, extraneous solutions. If the absolute value equation has variables on both sides, there could be extraneous solutions. This is a solution that needs to be rejected because it does not work when plugged into the original equation. All right, so again, this is why it's so important to be checking your solution. So 2x plus 12 equals 4x, and 2x plus 12 equals negative 4x. I want to get the x's to one side. I want to try to solve for x. I get x equals 6. On the other one, when I solve for x, I get x equals negative 2. So here's my solutions, but if I plug them back in, negative 2 is an extraneous solution. When I plug negative 2 in, 2 times negative 2 is negative 4. Negative 4 plus 12 is 8, which the absolute value of 8 is 8. And then if I do 4 times negative 2, I get negative 8. Well, 8 does not equal negative 8, so that actually doesn't work. All right, on the other one, I have the x plus 5 equals x plus 11, and x plus 5 equals negative x plus 11. If I solve for x, it subtract the x's, and I'm left with 5 equals 11, which is not true. So there's no solution to that one. The other one, I'm going to distribute the negative. Now if I combine the x's, I get 2x plus 5 equals negative 11. Move the 5. I get 2x equals negative 16. Divide by 2. X equals negative 8. And if I plug in negative 8 plus 5 is negative 3. Absolute value of negative 3 is 3. Negative 8 plus 11 is 3. Absolute value of 3 is 3. So those do work. All right. Absolute value of 2r minus 4 equals the absolute value of 2r plus 10. I'm going to get rid of the absolute value for the second piece. One of them is going to get negative, and I have to distribute that negative. When I get the r's by themselves, the first one cancels everything out, and I'm left with negative 4 equals 10, which is not true. The next one, I distribute the negative, combine, or get my r terms together. I get 4r minus 4 equals negative 10, add the 4, divide by 4. I get r equals negative 1.5, and if I plug that in, it does work. So this one has one solution, negative 1.5. All right, thanks, and see you next time.